I have a fascination with rocks and minerals. Real solid objects that aren't really going anywhere. I mean, you can take a rock and burn it, or make it explode, or throw it in a vat of acid and watch it disintegrate, or smash it with a hammer into smaller and smaller pieces. That's real physical matter that we all know is real. My mind is in what you can touch, what you can experiment on. Like biology, trees, plants, animals. Not experimenting on animals, obviously not, but I like dogs, I like cats, I like animals in general. I remember one of my ex-girlfriends introduced me to the red panda. The red panda is a very cute panda, and if you should take some time out of your day and look up some YouTube videos of red pandas, they're very, very cute little creatures. But the thing is that my mind is so well grounded when it comes to physical interpretations that when I see books like the one I'm holding in my hands, I'll show you in a second, I have to wonder, where has science been going for the past 100+ years? What have they been trying to do with what I would like to call rainy day conjecture? In my hands, I have a book by Richard P. Feynman. It's called 6 Not So Easy Pieces. And on the bottom of it, it says Einstein, Relativity, Symmetry, and Space-Time. And the introduction is by Roger Penrose. Here's the title of the book. I don't know, my iPhone is backwards because I'm doing a selfie with this, but this is what it looks like. You guys get that? Alright. Now in this book, I'm gonna list off all the sections. So pay attention to this for a second. I'm not gonna go too far into depth with explaining each section, but I'm going to tell them as they are. Chapter 1, Vectors. Symmetry in Physics, Translations, Rotations, Vectors, Vector Algebra, Newton's Laws in Vector Notation, Scalar Products of Vectors. Basically math. Nothing to do with physics at all. Chapter 2, Symmetry in Physical Laws. Symmetry Operations, Symmetry in Space and Time, Symmetry in Conservation Laws, Mirror Reflections, Polar and Axial Vectors, Which Hand is Right, Parity is Not Conserved, Antimatter, Broken Symmetries. So basically, that chapter goes over how if you have a physical law, there has to be an anti-law. In other words, there has to be symmetry between the laws, supposedly. But as far as we know, there's no anti-gravity, so placing symmetry on physical laws is kind of strange, if you will. It's a human construct invented to make sure that when you write a math equation, you have an equal sign in the center, and there's a variable here, and there's a variable here. That's all symmetry means. It's a mathematical construct that humans invented, and they try to force nature to work inside of symmetry. But nature clearly is not symmetrical. If you've ever seen a tree grow, it doesn't grow symmetrically. So I don't know why they're obsessed with symmetry in physical laws. Chapter 3. The special theory of relativity. Now, I like this special theory of relativity because it takes light time to travel. So when you're looking at the stars at night, they're not actually there because it takes all that time for them to travel to you. You're not looking at them as they are. I think that's what special relativity means, and that's it. And then it says, the principle of relativity. the Lorentz transformation, the Michelson-Morley experiment, transformation of time, the Lorentz contraction, simultaneity, four vectors, relativistic dynamics, equivalence of mass and energy. Now, that's all good. I don't really understand a lot of that. But one thing I wanted to point out is they have the principle of relativity in there. Now, for those people who want to pay attention closely, there is no such thing as the theory of relativity. It's the theory of special relativity, which explains the relation between light and space. And then there's a general theory of relativity, which tries to take special relativity and apply it to a force called gravitation. In other words, special relativity is an understanding of the universe, and general relativity is its bastard stepchild, which is called pseudoscience. But more on that later. Chapter 4. Relativistic Energy and Momentum. Relativity and the Philosophers, the Twin Paradox, Transformation of Velocities, Relativistic Mass, and Relativistic Energy. So, here we are talking about momentum, philosophers, paradoxes, and relativistic things inside of this theory of relativity. As we all know, there is no one theory of relativity, it's actually two completely different theories, made by the same man with the same intentions of explaining nature, but one's pseudoscience and the other one actually is valid. Chapter 5. Space-Time. The geometry of space-time, space-time intervals, past, present, and future, more about four vectors, four-vector algebra. In other words, this chapter goes off the deep end in trying to justify general relativity as an actual science, when the truth is that it's pseudoscience, it's fake science that we've been pushing upon our young minds for over 100 years, and I think my readers need to know that that's what it really is. It's just pseudoscience. It's idolatry of Einstein because he figured out special relativity, and then after that it just snowballed into oblivion, and now we believe that somehow there's a magic fabric in outer space that somehow bends and warps when there's nothing actually there. So there you go, the Emperor's new robes. Chapter 6. Curved space. Curved spaces with two dimensions, curvature in three-dimensional space, our space is curved, geometry in space-time, gravity and the principle of equivalence, the speed of clocks in a gravitational field, the curvature of space-time, motion in curved space-time, Einstein's theory of gravitation. In other words, Chapter 6 is the essential pseudoscience of all the 20th and the beginning of the 21st century. Chapter 6 is pure pseudoscience. It can be ignored, erased. This book can be burned, maybe except for like 5 or 6 pages of this book have anything to do with reality. But basically, this was essentially a pop culture type phenomenon, which in essence was designed to prop up a man who made one simple discovery, and then they took everything that man had to say after that, which was Einstein, and just completely ruin all the rest of science and completely destroy all free inquiry towards new ideas and alternatives towards understanding what gravitation really was and what time really is, and space, which actually doesn't have any properties. But Einstein made it had properties, which is very, very weird. Very, very weird. But basically that's about it with the book. And one thing you should notice about science books, which are popular culture science books. Now, this book was written in 1963, 1989, 1997, and the introduction copy with Roger Penrose in the beginning of it was written in 1997. So this book is around 18 years old. The latest edition was 18 years old. And the first edition was what's 37 plus 15? What, 53? 52? Somewhere around there? Anyways, if you'll notice, any reasonable, clear-minded, grounded physicist should be pointing out some things that are really, really, really obvious. Number one, they don't talk about chemistry. They don't even mention anything about chemistry in this entire book. Chemistry, the foundation for all of physical science, is not mentioned anywhere in this book. Believe it. That's a big sign that what they're doing here is engaging in pseudoscience. Number two, very, very, very little classical mechanics and classical physics is mentioned in this book. Very, very bad news as well. Number three, nothing to do with the planets or the stars or galaxies or quasars is mentioned here. Nothing about astronomy is mentioned in this book. Nothing. So what can we make of this book? We should throw it in a bonfire. Just throw it in a bonfire. There's nothing of use in this book. It's just trash. It's full of ego. It's full of, vanity. And it's full of nomenclature, fancy words, in other words, that have no relation to reality and really it just has no bearing on the future of the development of humanities sciences. But unfortunately, Mr. Feynman died in 1988, and this legacy is going to continue on for about 50 years until people finally realize that Mr. Feynman and all the people that came before him couldn't even explain how the earth formed and what the ground they are walking on really is. This is basically like 21st century alchemy. That's all it is. This is us being lost for over 100 years and keeping it all written down so when future generations look at it, they can say, oh, wow, we were really, really stupid. So no, I'm not going to burn this book. I'm going to keep it. Because in the future, when we finally understand more about nature, we're going to look back at things like this and think, wow, we idolized these type of people. We really looked up to them. And they were absolute idiots. Now, if we could just keep stuff like that and realize that humanity is progressing step by step, then maybe we'd actually have more to discuss at university level. Alright, today is February 14th, Valentine's Day, 2015.